Hello children, let's start the third video on redox reactions. Let's first see stock notation. Actually, whatever the oxidation number we are determining, how we have to write it. Suppose iron has 2 oxidation number, plus 2 and plus 3. How to write it? That is stock notation. So the oxidation states of elements exhibiting variable oxidation states are specified by Roman numerals such as 1, 2, first, second, third, fourth, etc. within parentheses after the symbol or name of the elements. This system was introduced by first time by the German chemist Alfred Stock and is known as stock notation. See this table, how we can show the oxidation number in parenthesis. This is called stock notation. Any of the example you can see, just look at it. See in the first, AU. Here AU here it is showing in the parenthesis 3 lines, means here gold is in plus 3 oxidation state. Next is Ti2O. So titanium here is in plus 1 oxidation state. FeO, this shows now how you will identify that this iron is in plus 2 or plus 3 oxidation state. How you will note, show, you have to show by this formula. Here iron in parenthesis 2 second and oxygen. Fe2O3, here iron is in plus 3 oxidation state. CuI, copper is in plus 1 oxidation state. CuO, copper is in plus 2 oxidation state. MnO, manganese in plus 2 oxidation state. MnO2, manganese here is in plus 4 oxidation state. So this is the stock notation. Means like this we have to show the oxidation state. I hope you have gone thoroughly with the rules for assigning the oxidation state. Let's revise it once more because we require it again when we are going to balance the chemical reaction and when we are going to see how many types of chemical reactions are there. So number 1, the oxidation state of an individual atom is 0. The total oxidation state of all atoms in neutral species is 0, and in an ion is equal to the ion charge. I hope you remember this. Group 1 metals will have plus 1 and group 2 will have plus 2 oxidation state. Fluorine always will show minus 1 oxidation state. Hydrogen almost plus 1. Oxygen almost minus 2. And in binary metal compounds, group 17 elements have an oxidation state of minus 1. Group 16 minus 2. Group 15 minus 3. So learn these rules for assigning the oxidation state. Let's proceed to redox reaction in terms of oxidation number. Redox reaction is a type of chemical reaction that involves a transfer of electrons between two species. An oxidation reduction reaction is a chemical reaction in which the oxidation number of a molecule, atom or ion changes by gaining or losing an electron. Redox reactions are common and vital to some of the basic functions of life, including photosynthesis, respiration, combustion, corrosion or rusting. Now here I am showing you few examples. Here you have to identify the oxidizing and the reducing agent. So what is the first step you have to perform? First step is that you have to write the reaction first. First you will write the reaction. Second step always will be yours to write the oxidation state on the top of every atom. As you can see here, one reaction is 2MnO4 minus plus 5SO2 plus 6H2O gives out 5SO4 2 minus 2Mn2 plus 4H3O plus. Like this, this reaction will be given in your question paper or in a question form. What next you have to do? Reaction is given, so you don't have to form the reaction. Next step is to write the oxidation state of every atom. Let's try to do this. Reaction is here. Here for oxygen, you know the oxidation state is -2. For manganese, if you don't know, you can calculate here. O is 4 here, means -2 into 4. It will give you -8, and one charge is here. So MnO4 is equals to -1. Mn is your X. Okay, X it is, and O4. 4 2s are 8, and charge is being we will do the minus with one charge, then it will come +7. Do it in your copy. Take a 30-second time, and just you also keep on writing the oxidation state of every atom on the top. I will move slowly here. Next is SO2. For oxygen, -2. Suppose you don't know the oxidation state of sulfur, we can find out here. 2 oxygen, 2 2s are 4, -4 is equals to 0, so S will be your +4. Take it out. Water, H2O. For hydrogen, +1. Oxygen, -2. This you have written of the reactant side. Let's proceed to product side. SO4 2 minus. For oxygen, you know -2. For sulfur, we will find it out. 4 2s are 8, and 2 minus. +8 minus 2 will give you +6. 2Mn2 plus. Do notice that charge has been given here. So you will not write that it is in free state. You will not write the oxidation state of manganese 0, +2 here. So oxidation state will be +2. H3O plus. Oxygen -2, hydrogen -1. Okay. So for this step we have done. We have written the oxidation state of every atom at its top. Okay. Now the next step is to find out whether the oxidation number of the element which is present in the reactant side is changing when it is present in the product side also. As you know that atoms can neither be created nor be destroyed. So whatever atoms are present on the reactant side, definitely they are going to be present on the product side also. So let's tally its oxidation state. First, C of manganese. In the reactant side, it is showing +7. What is happening to manganese in the product side? It is showing +2. So what you will see here, +7 to +2. It is reducing, it is decreasing or increasing? Definitely it is decreasing. +7 to +2. And you know, you have to remember one more thing here. Increase in oxidation number is oxidation, and decrease in oxidation number is reduction. Okay, one line you have already learned by heart, that loss of electron is oxidation and gain of electron is reduction. So what here, one more line you have to learn by heart. If oxidation number is increasing, it is oxidation. Okay, so +7 to +2 means oxidation number is decreasing. So we will see that MnO4 minus is getting reduced to 2Mn2 plus. Okay, now let's see the other. SO2. Sulfur here is +4, and in the product side it is showing +6. +4 to +6. Oxidation number is increasing. So what we will say here, it is oxidation is occurring here. Okay. So what is the result? The appropriate oxidation numbers are, the only atom which change are manganese from +7 to +2, a reduction, and sulfur from +4 to +6, an oxidation. Clear? +7 to +2, oxidation number decreasing, reduction. +4 to +6, oxidation number increasing, so it is oxidation. The reaction is a redox process. One thing is clear with this change in oxidation number, that this reaction is a redox reaction. Sulfur dioxide has been oxidized by MnO4 minus. Now this sulfur, we can see that this sulfur is being oxidized. +4 to +6, it is being oxidized. Which is the cause of this oxidation? MnO4 minus. So MnO4 minus is helping sulfur dioxide to get oxidized. So MnO4 minus will be called as oxidizing agent. Okay. MnO4 minus has been reduced by, now this manganese is getting reduced, +7 to +2. With whom help it is being reduced? It is being reduced by this sulfur dioxide. So sulfur dioxide is helping for reduction, so it is a reducing agent. Okay, is it clear? Let's proceed to see another example. One more reaction has been mentioned here. Noted down this reaction. NH4 plus PO4 3 minus gives out NH3 plus HPO4 2 minus. What will be the next step? We have to write the oxidation state of every element. Nitrogen here. As we know here, for hydrogen we will write +1. And if we don't know the oxidation state of nitrogen, we can find out here. Hydrogen +1, NH4 is equal to +1. One charge is here, na? So is equal to +1. N you don't know, so for N you will write X. Hydrogen is +1, so it will be +4 is equal to +1. So what will be the value of X? X is equals to 1 minus 4. So -3. Like this only we have to find out the oxidation state of unknown element. Okay. Okay children, let's proceed in PO4 3 minus. For oxygen, you know the oxidation state of oxygen is -2. And suppose you don't know about the phosphorus. What you will do? -2 into 4, 4 2s are 8. First you will write PO4 is equals to -3. Okay, charge you have to write. If it will be neutral compound, we will write 0. But if it is having charge, we have to write the charge on the other side. Okay, so for phosphorus you don't know, so you will write X here. Plus 4 oxygen, 4 2s are 8, that will be -8 is equals to -3. Solve it. What will be the value of X? X is equals to -3 plus 8. 3 minus 8 is equals to 5 plus 5. Okay, like this only we will find out the oxidation state of the element for which it is not given. Okay, this is okay. Like this only we will find the oxidation state of other element also. Now this reaction is not showing any change. You can check it here. Nitrogen -3, -3. Hydrogen +1, +1. Phosphorus +5, +5. Oxygen -2, -2. So you cannot find any change in the loss and gain of electron. So what we will see that the oxidation numbers show that no redox reaction has occurred. This is an acid base reaction because a proton but no electrons has been transferred. Okay, let's see one more example here. HClO plus H2S gives out H3O plus Cl minus plus sulfur plus S. Please note down this reaction in your copy and try to find out the oxidation state of every element present in this reaction. Now check it if it has become easy for you or not, or still you are feeling difficulty. Written in the same manner, we will find out the oxidation state of every element. H2 now from this scene, this is your reaction and this is your oxidation number. Now let's see. H2S has been oxidized, losing 2 electrons to form elemental sulfur. H2S, see here, H2S, sulfur, minus 2, 0. Whenever the number is changing from minus to 0, we will say that oxidation number is increasing. From minus it is becoming positive, though it is 0, but it is becoming positive. So oxidation number is increasing. So H2S is being oxidized. Okay. Now since H2S donates electrons, H2S donates electron, it is the reducing agent. HClO accepts these electrons and is reduced to chloride minus. Since it accepts electron, HClO is the oxidizing agent. Okay, children, do more practice with the examples which is given in your book to find out where reduction is occurring, where oxidation is occurring. When you will be able to find this oxidation and reduction, then definitely you will be able to analyze the oxidizing and reducing agent. Okay, let's proceed. Identify the oxidizing agent and reducing agent in the following. 2 more reactions are here to find out the oxidizing and reducing agent. Let's see the solved one. This is your reaction. I have assigned the oxidation number. In the first reaction, 2H2 plus O2 gives out 2H2O. Hydrogen 0, it is becoming plus 1. Oxygen from 0, it is becoming minus 2. So it is clear, oxidation number increasing, oxidation number decreasing, reduction. O2 was reduced. In the O2 was reduced, oxygen is the oxidizing agent. Hydrogen was oxidized, hydrogen is the reducing agent. So you can understand here the moiety which is being reduced, that will be your oxidizing agent. And the moiety which is being oxidized, that will be your reducing agent. There will be many quick steps for you all to memorize the oxidizing agent and reducing agent. Whichever you find easy, just learn it by heart. Okay, see the next reaction. Copper plus 4HNO3 gives out copper nitrate plus NO2 plus H2O. Okay, in this, what will be the next step? We will assign the oxidation state of every element. After mentioning the oxidation number, now see the result. Copper was oxidized. Copper here is 0 and here it is becoming plus 2. So 0 to plus 2 means oxidation number is increasing. So it is oxidation. So copper was oxidized and copper was oxidized. Copper is the reducing agent. Whichever moiety is being oxidized, that will be the reducing agent. and whichever moiety is getting reduced, that will be your oxidizing agent. HNO3 was reduced and HNO3 is your oxidizing agent. Okay, let's proceed. Types of redox reactions. I think I should stop here, and this I will discuss in my next lecture. Types of redox reaction plus how to balance the chemical equations. This will be my last lecture. I think so. I should be able to complete in one lecture. If it will be not, then I will make it in two lectures. Okay, so next lecture will be about different types of redox reactions plus how we will balance the chemical redox reactions. Okay, so thank you children. Read whatever has been taught and whatever will be taken as a lecture in the next video. So please read it, and whatever we have done today, please practice. Many questions are there in your book. Need not to worry about getting more questions. If you want, I can make available more questions for you all. Okay, so first practice whatever questions are given in your book. Okay, try to understand what is oxidation, what is reduction, how oxidation number is increasing, how decreasing, oxidizing agent, reducing agent. Go through every thing, and then I will start my next lecture on different types of redox reactions plus balancing of redox reactions. Okay, thank you children.